Hi guys, in today's video we're going to learn on how to solve problem involving proving identities. We just do a recalling session on the formulas that we have learned earlier. Right, tangent theta is known as sine over theta. Cosecant theta is known as 1 over sine theta. Secant theta is known as 1 over cos theta. Cotangent is known as 1 over tangent theta. So tangent theta we already learned earlier, which is sine over cos. So that means the cotangent should be cos over sine. And then we have another three more formula. Cos square theta plus sine square theta is equal to 1. 1 plus tangent square theta equals secant square theta. And cotangent square theta plus 1 equals to cosecant square. So of course, this formula, by just saying it won't do any good. We need to know how to utilize this formula in the proving identity. All these formulas is the fundamentals for you to solve the proving identity formula. These three actually we have a ways to memorize it. Okay, my way will be, okay, since this is a cosecant, okay, the first alphabet is C, so the the reciprocal of C will be S, so that will be 1 over sine theta. And then here is secant, the first alphabet is S, so the formula should be 1 over cos, because since this is S, this should be C. This is C, this should be S. And then the cotangent expressed by itself, which is cotangent, so it's 1 over tangent. Alright, so without further ado, what I'm going to do is we're going to straight go to the question. So if you see here, we have this question that we want to prove the left equals to right. So we have to pick a side, either left or right. So normally students have this dilemma where which side they want to choose. I play with this three golden rule, whereby the side that I choose must have more than one function, and at the same time it must be considered complex enough. So if you look here, this cos is only one function and not complex, whereby here is complex and more than one function. So what I will do, I will definitely choose the left hand side, because it gives us more leverage and advantage for us to play around with it to narrow down to this one single function. If we start off with this, for us to expand it will be kind of hard, so this will be the best kind of choice to choose side. So from the left hand side, what we're going to do is that we're going to refer back to our formula, whereby cos square plus sine square equals 1. Why I refer that is because this is a square, so obviously the best candidate we have is this. And if you spot here, the final answer or the side that we want to prove into is contain cos. That means we must eradicate this sign by all costs. So what I'm going to do, I write in this formula, I'll shift this sign over. So when I shift this sign over, it shows 1 minus sine square x equals to cosecant. Can you see this? This formula and this entire thing is the same. You see, these two is the same thing. So I can just replace them with cos square instead. So that's what I do. I replace with cos square over cos x. So we know cos square is actually cos times cos over cos. Since they are same, we eliminate, we get cos x. So yes, we have proven. Okay, so let's try our theory in another question. So if you see in the second question, whereby again we have some side that we need to prove. Okay, so we play with our two rules, whereby it must contain more than one function, at the same time must be complex. If you look, both sides is considered complex for me, but this side only have one function, whereby here have two functions. So obviously we'll choose the one with the more than one function. So I'm going to write here LHS stands for left hand side. I'll pick up from here first. Okay, since before we even proceed, we need to look what in our the side that we want to prove contain of. So we see here we have cos. That means we must eradicate this sign by all costs. So I will use back this formula here, which is our general formula, and I will make the sign as a subject so that I can eliminate the sign. So when I shift this cos there, we know this sine square is the same thing, and it has a brand new formula. We will take and replace inside here. So it become cos square minus this new formula. All right, so negative positive gives you negative, negative negative gives you positive. Cos square plus cos square give you 2 cos square x minus 1, and yes, we have proven. All right, so by just playing these two fundamental formula, we can solve a lot of problems. So let's just do one last question. Okay, so if you look here again, this is considered complex. Okay, both side has a two different functions. So it's up to you where you want to choose. You can choose the right or left, but of course by imagining, tangent is going to give you a complex and cotangent is going to give you a complex. But secant and cos, it's kind of straightforward, because secant is 1 over a cos and cosecant is 1 over sine. So the best candidate will be left hand side. So I just express them back. Tangent is known as sine over cos. Cotangent is cos over sine. So what I'm going to do here is that in a general law of maths, when a fraction's denominator not same, we are supposed to make the denominator same. So I will just make the denominator same, whereby since here is sine x, I'll times sine x. Here's cos x, I'll times cos x. Okay, so in that way we make the denominator same, and then sine x times sine x square, Cos times cos is cos squared. So we know this function that we learned earlier is equivalent to 1. So that means it's 1 over sine x cos x. So we are almost reaching to our proving part. So we can split them, become 1 over cos, 1 over sine. We know 1 over cos stands for secant, 1 over sine stands for cosecant. So yes, we already proved them. Alright. So if you notice, we only play with these two rules and several formula that you need to remember. So just use these two rules whereby pick a side which is complex and more than one function, and you're good to go. I hope that this video helped you to understand better on how to solve proving identity. Thank you.